Alright guys, so we're going to start Unit 4, Lesson 1 on congruent triangles. This will be the first set of notes for the lesson. What I want you guys to do is you have the notes packet, and as I complete the notes packet, I want you to follow along. I'll also get you started on the assignment for this section. Again, I plan on this taking about an hour and a half, so if you get done quicker, then you can move on to section 2. If you need a little bit more time, then you have to complete it at home. But make sure you pause the video at the appropriate moments, and when you're in class, make sure you stop and ask me questions. I'll be floating around, hopefully touch base with you guys. Okay, we are in day 1 of the unit plan on congruent triangles. So today we're going to be focusing on isosceles and equilateral triangles. And if you notice here, this video is available on YouTube on the Disney Nerd Dad webpage. There's also a Khan Academy video on Xbox under Geometry, Congruence, Isosceles and Equilateral Triangles, and video number 3. What I want you to do right now, though, however, is to go to your notes for Unit 4, Lesson 1, and we will get started. Okay. First thing we want to be able to do is we want to be able to classify a triangle by the amount of angle, by the degree of the angles. So in these should be all review. We have an acute, an obtuse, a right, and an equiangular. And of course, you guys should know what they look like. An acute triangle has all small angles. An obtuse triangle has one big angle. A right triangle has one 90-degree angle. And an equiangular triangle looks like an acute, but all of the angles are congruent. And that means that all of the angles are equal to 60 degrees. If we look at a triangle by its sides, and this should also be review, you have a scalene, an isosceles, and an equilateral. A scalene triangle, if I have 3 sides, there are 3 different measures. An isosceles triangle, if I have 3 sides, 2 measures are the same, and the base side is a different measure. If I have an equilateral triangle, then all 3 sides are the same. Now, an equilateral triangle is also equiangular. This is going to be important when we're talking about how we compare sides to angles later on. So, an equilateral triangle also has all 3 sides being equal. Now we could name various types of triangles, and that's fine. And if you guys take a look at this, I'm going to name one. So for example, I'm going to name triangle ACB. Triangle ACB is a right scalene triangle. So what I want you to do now is I want you to pause the video, and in your notes I want you to name 3 more triangles in this picture. So when I come around and look at your notes, I'll be looking for 3 more triangles that you've correctly named in the picture. Okay. In Chapter 4, in Unit 4, we're going to talk about congruent triangles. And we're going to talk about the corresponding parts of congruent triangles corollary. And we can abbreviate that as CPCTC. Okay, so triangles that have, we're going to take that out, congruent sides and congruent angles are congruent triangles. So, A, B, C, and D, E, F are congruent. AB is congruent to DE, BC is congruent to EF, so forth. Angle A is congruent to angle D. Angle B is congruent to angle E. And you get the idea. And basically what that means is if the two triangles are congruent, the sides and the angles of the two triangles correspond in the same order as the letters that name them. So like I said, if this is ABC, this is DEF. And as we talked about on the other side, there are 6 corresponding parts. So angle A is congruent to angle X. Angle B is congruent to angle Z. Angle C is congruent to angle Y. Line segment AB, XZ, BC, ZY, and AC, XY. And that's if they're congruent, okay? Now, among congruent triangles, we have to choose between potentials of isosceles and equilateral. And so we have to understand that the isosceles triangle will have 2 congruent sides, and so therefore 2 congruent base angles. And then this third side and the vertex angle will not be congruent to the other 2. And that's the rule that we've just covered here in the notes. If 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So if AB is congruent to BC, then angle A is congruent to angle C. Take a minute and go ahead and try to answer example 1 and 2. I'm going to pause the video and then we'll come back and we'll talk about the answers. Okay, so in this triangle here, the vertex angle is 80 degrees. And as we've talked about in Unit 3, there are 180 degrees in a triangle. If these 2 are congruent, then x and y split what's left. So x is equal to 50 and y is equal to 50. Likewise, in this one, these 2 are congruent. And so if y is equal to, we got to figure out what this is as well. If this is 100, then both of these are 40 degrees. Y is equal to 40 degrees. If x is equal to 40 degrees, then this is equal to 140 degrees, because as we've talked about, a straight line is 180. And so then we have 40 degrees left for x and whatever this angle is. So x is equal to 20 degrees. Likewise, if 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So if angle A, in this picture above, is congruent to angle B, then these 2 sides are congruent. BC is congruent to CA. And so if we look at this example here, these 2 angles are congruent. So this angle goes to a value of 8. That angle also goes to what value? X is 8 units long. The other question has to come down to what y is. Well, again, how many degrees are in a triangle? 180, so we know that y has to be 20 degrees. Take a look at picture 2, pause the video, we'll come back and talk about it. Okay, hopefully you took a look at this and you figured out that if both of these angles are 20 degrees, there's 180 degrees in a triangle, so these are 40, so then y is 140 degrees. Also, you remember that if two angles are congruent, the sides opposite those two angles are congruent. Since 5 is opposite of 20 degrees here, then the side opposite the 20-degree angle here would also be 5 units. Equilateral triangles work in the same way. So if we were going to look at equilateral triangles, we can find sides or angle values. So if I have an equilateral triangle here, I can take any of these two sides in an equilateral and set them equal to each other. Now, the easiest way to do this would be to pick the one without a coefficient at the end and set it equal to the simpler of the two. 2x is equal to x plus 9. So when I subtract x, I get x is equal to 9. Then we can verify this is an equilateral triangle by, of course, plugging it in, as we've talked about. So here, this side length is 18. This side length is 18. 3 times 9 minus 9 is also 18. And I have an equilateral triangle. An isosceles triangle works a little bit differently. It gives me the directions of RS is congruent to RT. So if RS is congruent to RT, then I have very specific rules I have to follow. I can only set 2x plus 9 equal to 4x plus 1. So then when I solve, I can get 8 is equal to 2x, subtracted 2x, subtracted 1, and x is equal to 4. And so then when I plug back in, I get 17 for this side, 17 for this side, and 8 for that side. I've met the rules of a isosceles triangle. I want you guys to take about a minute or two and finish answering questions 3 and 4 here at the bottom of the page. I'm giving you a picture to help with 4, and then we'll go over the answers. Okay, so hopefully you guys took a minute and answered these two questions. For number 3, you had to draw a picture, and you can see I drew a picture of ABC, and I set the 3 sides, and then I basically had to pick 2 because the equilateral and set the 2 equal together. So I did that, and I finished out with 13 minus d equals 7 plus d. I added d, I subtracted 7, and so I got 2d is equal to 6, d is equal to 3. When I plug in d on all 3 sides, I get all 3 sides equal to 10, and that meets our rule for equilateral triangles. The last thing that we want to discuss is what do we do when we're just trying to figure out if a triangle is congruent to another triangle. So you can see with the picture, I put the appropriate numbers on each side, and then I put x plus 1 where it belongs. And so then I realized that x plus 1 has to be equal to 6. And so then I just solved for x. And so that made my information match up. That completes the notes for the first unit. There are a couple things we have to do for practice that I want to now go over. And so we're going to switch to the practice workbook. But first we're going to look at the assignment. For day 1, the assignment was page 91, 1 through 7, 107, 1 through 13. So I want to go ahead and take you to page 91. On page 91, essentially I'm just getting you to practice understanding that angles are congruent to angles and sides are congruent to sides. So what I want you to do right now is to go ahead and complete 1 through 7, and then when you're done with 1 through 7, bring it to me to check. I'll go ahead and get you started on number 1. If you see this polygon here, the shapes are congruent. So angle 1, which is angle LGH, matches angle FAB. So angle 1 is 110 degrees. So for 1 through 3, you're just going to go through and tell me angle 1, 2, 3, 4, 5, 6, 7, 8. Okay? And again, for this one, understand that this is a straight line right here to help you find that angle. For 4 through 7, I just want you to name the congruent pieces like we did in the notes. So where it says 3 pairs of congruent sides, it says CAT is congruent to JSD. So the first side is CA is congruent to JS. So you should be able to find me 3 more sides. Okay? And go ahead and finish 4 through 7. Alright, that takes care of page 91. The other part of the directions were to complete page 107, 1 through 13. So we'll go back and do that. Yep, 107, 1 through 13. And again, this is just working on the idea of naming congruent pieces and then using some of the algebra to understand the things that are equivalent. I'm not going to go through 1 through 4 because those are just like what we just did, but I am going to go to number 5. For number 5, this is a linear pair, and so this angle will be 65 degrees. Because this is an isosceles triangle, that means x is also equal to 65 degrees. And so if x is equal to 65 degrees and this is equal to 65 degrees, this is a triangle, and so we add 65 plus 65 and get 130. We subtract that from 180, y is equal to 50 degrees. Now, some of these problems are going to require you to use a little bit of algebra, and some of these problems are going to require you to kind of think outside the box. Again, remember what you've been taught about 100 degree, 80 degrees in a triangle, and an equilateral triangle, all degrees are equal to 60. You should be able to get through 5 through 13 no problem. Any questions, don't hesitate to ask me. When you're done with the problems, bring them to me to check. Once we're all checked off, we've talked it through, you'll be able to move on to lesson 2.